Question 6a. Okay, we have to find the value of p, so we will try to make the modulus the same so that we can remove the same modulus from each of the term here. Okay, and keeping in mind that the modulus of this is the same as the modulus of this. So we will write the first one. Okay, the second one, we can factorize out the 4, leaving us with a 2x minus 1, and we will keep the 1 on the right hand side. Okay, now since they have 1 minus 2x and this is a 2x minus 1, so we can swap one of them. Okay, we can split this and we will swap this. Now since everybody has a 1 minus 2x, we can actually remove it. And then we just compare the value that's left. So 9 plus 3 times 12 will give me a 12 equals to p. Therefore, p is equals to 21. For the second part, we have to use the part 1 answer to solve the equation. So we have to make whatever is given look like part 1. Okay, so suppose I rearrange them. And if I multiply everything by a 3, you can see that now my left hand side is the same as what was originally given, so I can replace them with the right hand side function. So this is equals to 21 of 1 minus 2x equals to a 3. So I will solve for this only. So it means that 1 minus 2x is equals to 1 over 7, and removing the modulus, it will become 1 over 7 or negative of 1 over 7. Then I just have to solve for my x. So that's my answer for 6a part 2. 6b part 1, I have to sketch both graphs on the same diagram. Okay, so I'll try to sketch the second one, which is easier. It's a graph which is going downwards and cut at 1. Okay, so cut at 1, going downwards where the gradient is 1, so it will be a graph that's going down this way. Alright, then I'll label the axis. The intercept here will be a 1, and then the y-intercept will be a 1. Okay, now I'll label the graph. This is y equals to 1 minus x. Now since I have to keep within the range, so I will try to extend my line. Okay, so when it is at x equals to 3, then we find the value for y. So when x equals to 3, y will become minus 2. And when x equals to minus 2, y will be at 3. Okay, so something like this. For the other graph, this is originally 1 plus 2x, so it is a graph which is going upwards also at 2, but with a steeper gradient. So when x is equals to 0, okay, the y should be at 1, cuts the same point. And when y equals to 0, the x originally will be at minus half. Okay, I got to shift my graph a little bit lower so that I got space here. Notice I did not draw my graph here because I know later I need to flip it out, so I keep that one first. Now I need to extend this part here. Check that when x equals to 3, we have to sub this value inside. So that will give me a y equals to 7. Okay, like this. On the other side, if I check x equals to minus 2 and I put it inside here, I will get a minus 4 plus 1. So that will be a minus 3. With the modulus, it will go up to 3. Okay, so we'll draw the graph like that. Okay, then we can label the graph now. So this part here is y equals to modulus of 2x plus 1. Okay, for the last part, I need to find the number of solutions for the graph. Now, if you look carefully, the graph is actually this one and the other graph which is over here. So look at the number of solutions. It crossed at one point here. Okay, since x equals to minus 2 is acceptable, and the other graph intersection point is here. Okay, so there's 2 intersections, so your answer will be 2.